and welcome back to Introduction to Physics. My name is Paul Eric, and I teach physics, astronomy, and geology at Ozarks Technical Community College in Springfield, Missouri. This series of videos is going to be a review for the unit exam that we're going to have in Introduction to Physics. And as you can see, it's going to cover lesson number 2, lesson number 3, lesson number 4, and then lesson number 5. Now what we're going to do though is we're going to start off with lesson number 3, which introduces you to how far something travels and how fast it's going, and then what its acceleration is. And then in our next series of videos we'll review lesson number 2 and then lesson number 4 at the same time when we do Newton's laws of motion. So we're going to begin with lesson number 3. So lesson number 3 is on linear motion. So please read the lesson objectives because there's going to be a test question that goes with each one of them. And then out of your textbook, Conceptual Physics by Paul Hewitt, this is going to be chapter 3. So let's start by reviewing what do we mean by the words speed and velocity. Speed is going to be a scalar, meaning it's just going to be a number. Velocity is going to be the speed of an object, and then it also includes what direction it's traveling in. So velocity is going to be a vector. For right now though, all we need to know is we're going to treat speed and velocity as being the same thing. So our definition here of what average velocity is going to be, so velocity average is going to be the distance that something travels, and we're going to use the letter r to represent distance, and then divided by the amount of time that it takes it to do it in. And then you should also know what are the units for speed, which is going to be meters per second, because distance is going to be meters and then time is going to be seconds. So put it together and the official metric units for speed or velocity are going to be meters per second. So what would I want you to be able to do on the exam with that equation? So notice that you've got 3 letters, and then I've got to give you 2 of the quantities, and then you can solve it for the third one. So in this example here, a car is traveling 10 meters in 2 seconds. What's its average speed? So we know what the r is and we know what the t is, so we just plug it in there. But notice that this equation could be written 3 different ways. So if we wanted to write it for r, then this equation would be that r is equal to v average and then times t. So that's another version of this same equation. If you're given the velocity and if you're given the time, then you could calculate the r. And then there's a third version of the equation, which is going to be that t. So if we solve this equation up here for the letter t, or solve this one for the letter t, we end up with that t is going to be equal to r divided by v average. So notice that on the exam, I could give you 2 of the letters, and then you have to plug the letters into the formula and then solve it for the third one. Now, you don't need to memorize all 3 of these equations though. So as long as you've got this one up here, you're okay, because you can always rearrange the equation to solve for whatever you need. But these are the 2 alternate versions of the same equation. Okay, then the next thing that we did was the definition of acceleration. So acceleration is going to be given by the letter A, And notice it's very similar to this one over here. So it's going to be the change, so that's what the triangle means, is the change in the speed over time. So it's the change in the speed. It's not just v over t, it's the change in the v over t. And so another way of writing that is, instead of delta v, you could say v final minus v initial divided by t. So this one is the same thing as this one up here. And so notice that you need both the final speed and the initial speed in order to be able to use the equation. And just like we took this equation and we turned it into these two equations, we can take this one and then rearrange it for basically any of these letters. So I'm not going to do that, but you could if you wanted to. So here is an example of how you would use the formula. So remember that acceleration changes your speed, so that you can think of acceleration as being the master control knob, because whatever your acceleration is, that's going to control what your speed is. And then once you know what your speed is, that's going to control where you're located at. So the acceleration is kind of like the master control knob when we're talking about these equations. So again, here are some typical accelerations. All right, then we have our sign convention, and we're going to say that if you go up, then that is going to be a positive number. If you are going down, that's going to be a negative number. If you're going sideways to the right, that's going to be a positive number. And if you're going to the left, that's going to be a negative number. So notice that velocities can be positive or negative numbers depending on which way it's going. R's can also be positive and negative numbers. What about T's? So can you have positive and negative times? Well, theoretically, a negative t means you're going backwards in time. And we're not going to be doing that in here. So that we'll always have positive t's when we look at these equations. And then you can have positive and negative accelerations. So it's telling you the direction that you're going in. All right, let's take a break, and when we come back, we will review the how far equation and the how fast equation.